Let's say you came across what you have on the whiteboard for the first time as a Jambite. It's been a while I deposit video on my YouTube channel as well as on my TikTok page. So guys, let's take a look at what we have on the whiteboard together. We are given an equation like this, and they say from the reaction above, calculate the standard heat change of the standard enthalpies of formation of carbon dioxide, water, and carbon dioxide in kilojoule per mole are minus 394, minus 242, and minus 110 respectively. If you are given a question like this, since they have made mention of enthalpies of formation, so we can easily say that this type of question is a good example of heat of formation. And when we look at that, the meaning of heat of formation, we look at it as the reaction at which 1 mole of a substance of its own element under a suitable standard condition. So we can easily say we have this. The enthalpy of reaction is equal to the standard heat of formation of products minus standard heat of formation of reactants. So what you have in this small bracket represents product and reactant respectively. Now, if you are given a question like this, you need to identify the product side and the reactant side easily. Now, here is the reactant side, this R, while here is the product side. In that case, according to what we have on the whiteboard, this water and carbon monoxide value are given respectively. So the value of carbon dioxide is, you can put it here so you won't get confused. For this water, we have this, and the last one, which is carbon monoxide, I have this. Now, from that reactant side and product side, let's write this equation. I can easily say that I have this, or enthalpy of reaction is for this. Don't forget, I made mention that the standard heat of formation of product side. For this product side, I have CO2 plus hydrogen gas minus the standard heat of formation of the reactant side. I have CO plus water. Now, the value of each of this compound respectively, or substance respectively, for CO2, we are given this minus 394 plus, not one thing, since we are not given the value of hydrogen gas, that will be 0. So before we continue, or before we solve further, let's take a look at it. If this particular compound is, or equation is balanced, I have one carbon here, I also have one carbon here. The number of oxygen we have at the reactant side is 2. 1 plus 1, we have 2. At the product side, we also have 2. The number of hydrogen gas is what? 1 mole, which is this, as well as what we have at the what? The product side. Now, what is the value of carbon monoxide for this? Minus 110. The value of water is going to be this, plus, minus. So if we are to solve a question like this, guys, we can easily say that since we are given a value like this, plus times minus is minus. So we said we have minus 110 minus 242. Are you with me now? So we said we have minus 394 minus, open a bracket, we have minus 352. You close the bracket. So in that case, minus times minus, we have plus. So we have 352 minus 394. So let's check. So when we have minus 392 plus 352, so we have minus 42 kilojoule per mole. So guys, if you are given a likely question like this, as far as Jamb is concerned, you don't have to panic, in as much as you understand the concept of enthalpy. And mind you, for you to solve any question relating to heat change, be it heat of combustion, where we have the formula, be it heat of formation, which you have on the whiteboard. So if you have to solve a question like this, you don't have to panic, irrespective of how they placed the question. You just need to understand how to get each of the parameters for the reactant side as well as the product side. So in that case, our final answer is minus 42. So irrespective of how they place the options. Now, from that question, option C is a correct answer. Now, note one thing. If you are solving any question, irrespective of either heat of combustion or heat of formation, if it is negative, that is exothermic reaction. If it is positive, that is endothermic reaction. So guys, if you are just coming across this video for the first time as a Jambite, do well to like, share among your colleagues, and if you have any question, do well to drop it in the comment box. Thank you.